Hi, so in this video I am going to explain the rest of the part of the half adder, that is the test bench part, and the output part, that is the EP wave. Okay, so let's move towards the test bench part. So for the test bench, here also we have to give a entity name. Okay, so we have to write as entity. Then here we have to give a name. So I'm taking a name as TB. TB means test bench. Then half adder. You can take any name, okay, no issue. You can take any name. Then is. After that, we will end this entity as end entity TB underscore underscore half adder, then semicolon. So something different, no, means we have write the entity, but we didn't use any port. Unlike in the design part, we have also done an entity like entity half adder, and we wrote some port like A as input, B as input, some carry as output. But here we have write the entity as TB half adder, but we just close as soon as it started. Why? Because this test bench is the king of this process. Means the test bench is so powerful that it already knows that how many input and how many output will be there. Means think like that, you are in a room and you want to do a circuit. For that circuit you need a AND gate, OR gate, or different type of gates you need, and you have make a list, and you check the whole room that whatever ICs are present in your list, each and every IC are present in your room, in that room only. Then there is no need to buy any extra IC or any extra thing. So that's mean this test bench is also like the room, that whatever is present in your list is already present in that room. So no need to make any list, because you know that whatever you will think that yes, I need this gate, it is already present in that room. In the same way, if you think that no, I will take A as input, B as input, but that input or output is already present in the test bench, it is as much as powerful like that. Okay, so we will, after this we will go to the architecture part. Architecture, here I shall take the name as behavior. Okay, behavior architecture behavior whose of TB underscore half adder. Okay, after that is, then we will take the component. Here we will not take as the port, we will take the component of adder is. Means here we are assigning the component, means that what are the ports we are taking, A, B and C, we are just assigning that from the design part, that we are taking the component as A, B, sum and carry, which we have already written in the design part. We are writing in the test bench also, like as component, that this component is present in the half adder. What is that? That is A, B as input, sum and carry as output. Okay, this whole thing has been explained very deeply in the AND gate. I have already put it the link in the description box. Okay, so you can check it from there only. Now we will write as port, then first bracket, then A, it is as input, so in std underscore logic semicolon. B, it will also input, int means in std underscore logic, then output is the sum, out std logic, then carry is also the output, out std logic. Then we have to close the port, first bracket, semicolon. Okay, then we have to also end the component, end component. Done. Component part is present. Now we have to give the signal. Signal means at first the signal, you think like that, whenever the green signal is given in the traffic or in the railway station, then only train moves ahead, right? Otherwise train will stop and blow the horn for the signal master to give the signal as immediately as possible, if the front or if the ahead destination is clear. Okay, so in here also we have to give the signal. So for the beta starting, for the beta starting without any mess or without any hurry starting, we will just start smoothly by giving the input or starting as 0 and 0. So here are two inputs has been taken, A and B, so the start will be from the 0 0, as in the truth table only you have checked that where we from which portion it start, from the 0 0 only na. So here also the signal will be start from the 0 0 for a smooth starting. Okay, so signal TBA. Here we are taking TBA because we are doing the test bench, not the design part. Okay, so we have taken the component as the design part, but the whole thing will be happen in the test bench, because test bench is like a testing your design, testing your hardware. Okay, so TBA, we have taken a new name. TBA means test bench A. You can take any name. Okay, std logic, then colon equals to, it is like equals to only, but here the operator will be different. For this the equals to will be colon equals to, then single quotation 0, single quotation close, semicolon. Once again, signal TB B std underscore logic, signal quotation equals to, colon equals to, single quotation 0. Okay, then output, signal TB sum, std logic, then signal TB carry std logic. For the output it will generate by the machine only, so we will not give any starting symbol or anything. Okay, then we have to close. Okay, signal complete. After this we have to write as begin. We will start the process part. Begin as UUT, then write as, give a name as half adder. Okay, half adder. Here we have to give the port mapping have to be done. Map A as equals to greater than TBA, means A is mapping with the test bench A. Okay, then B equals to greater than TB underscore B. B is mapping to TB underscore B. Then as same for sum equals to greater than means is equals to. Okay, sum equals to TB underscore sum, carry equals to TB underscore carry. Then begin is complete. In the next process we will do the process part. Process part means we will give the input and output will be generated by the test bench. Input means like 0 0 0 1 1 0 like this. So for that we have to write STIM, then underscore proc, then colon process. Okay, after that begin. Then for the first case, TB underscore A less than equals to quotation, single quotation 0, colon, then TB B less than equals to 0. Then wait for 10 nanosecond. This means that whenever the input will be getting as 0 0, then it will wait for 10 nanosecond, a line will be shown, then again it will be strike, means it will be strike or it will move forward for the next input. If you don't give as wait for 10 nanosecond or 20 nanosecond or anything else, then it will give a messy type of thing, means the first input like 0 0 0 1 1 0, those all will be so small or so fast up and down, you cannot check it means deeply. You will only see the exact output of the last output, that is 1 1. Okay, before those 3 output or 3 input output will be not get if you didn't use any wait for any nanosecond. Okay, so here I am using that 10 nanosecond. Now next input will be 0 1, then 1 0, then 1 1. So I am copying the TB less than equals to this part, then enter paste. Then I will change TBA less than equals to 0 will be 0, TB less than underscore B less than equals to, it will be 1. Let's change into 1, then wait for 10 nanoseconds. Same again, it will be 1 0, so TB underscore A, it will be 1 and B will be 0. Okay, 0 0 0 1 1 0. Next the last will be TB underscore A, it will be 1, TB underscore A, it will be 1. Wait for 10 nanosecond. Okay, then stop the wait, otherwise it will be loop forever, infinite loop will be happen. So you need to be give, then end process have to be stop, then end architecture behavior, it have to be stop. Okay, so the whole half adder has been complete. The whole adder has been completed. Okay, now we have to run. For the running, see this entity, the test bench entity TB underscore half adder underscore adder, you have to copy this and paste in the top entity portion. Okay, paste here as the in the top entity portion. Now click on this run button which is present in the upper bar and let's check. During the run only it will be show if any error is occurred, here only it will be show that what type of error has been occurred. If no error has been occurred, then it will be generate the EP wave. Okay, see, this is the EP wave of the half adder and this is what we want after doing the code. Okay, so see, let's check the first input output. Okay, if you see the half adder truth table, then you can get the then you can means check the result that whether this your hardware or this your EP wave is giving the correct answer or not. See, for the A and B, for the first input A and B, the sum is 0, carry is 0. Yes, for the design part also, your A, B, carry is 0, sum is 0. Okay, this one is correct. Then the next part, that is 0 1. For the 0 1, sum is 1 and carry is 0. Correct. For the design part also, sum is 1, carry is 0. Correct. Now for the 1 0 part, see, 1 0, carry is 0, sum is 1. In the for the design part also 1 0, carry is 0, sum is 1. Okay, now for the last one, 1 1, see, carry is 1, sum is 0. In the same way, design part also 1 1, carry is 1, sum is 0. So the half adder is fully completed and you can also conclude that half adder is correct, means your hardware is correct, your hardware logic is fully correct. So here we have completed our half adder.